Okay, so 9.2 parabolas. There are two different types. We have horizontal and vertical.
Where are the circles?
We're going to do those next.
She's recording.
Yeah, I am recording. So a y-squared parabola, it has a vertex at 0, 0. Uh-huh. If you look at the equation, so it is y minus k squared equals 4p x minus h. So what that means, like what the 4p is it has to do with the focus and the directrix. Like you use that number in order to solve for the directrix and the focus. And they are p units away. So like wherever your vertex is on your parabola, you'll go to the left or to the right or up or down to get your focus and your directrix. So I'll kind of show what that looks like here in a minute. But it's always the number that is in front of, not the squared term. So in the y squared, it's 4p, it's the number in front of the x. And then when you have a vertical one, it's in front of the y. So whatever coefficient is in front of the x here, which we would say a 1, that number is equal to 4p. So if 1 is equal to 4p, then p equals what? Like if I were to just solve. 1/4. Perfect. Your axis of symmetry is just where you could cut that parabola in half. So we have y squared equals x. That's the simplest form. If I wanted to kind of expand that and find like an h and a k, it looks like if I put this in standard form, y minus 0 squared equals 1 x minus 0. So sometimes having the minus 0 and the minus 0 helps, because then you know, okay, it's centered at the vertex, it's at 0, 0. So my axis of symmetry is always your k. My k in this case would be 0, so y equals 0. So I'm just going to put a dashed line at that horizontal line at 0. And my directrix is always away from your parabola. So if you were to graph this in your calculator, you could go ahead and type this into your calculator. If you have the new one, I think it lets you type in y squared equals h. I'm not completely sure. But if it doesn't let you type in a y squared function, then you could also type in y equals the square root of h and y equals the negative square root of h. Like if I were solving for y, like plus or minus square root of h for the graphing. So if you were to graph this in your calculator.
So it already says f of x equals, what do we do here? Because it won't let you delete it.
Okay, so if I were to copy what the graph shows, then you could even plot points, but you would always have your calculator for this type of thing. It has a vertex at 0, 0. It points to the right because it is positive. So if you have a horizontal, that means you're going to have a y squared. So y squared is horizontal and x squared is up and down. It opens to the right if you have a positive y squared, and it opens to the left if you have a negative y squared. Okay, so you might want to write that in your notes, that if you have a positive, it opens to the right, or it opens right, and if you have a negative, then it opens left. Kind of similar to when you have an x squared, positive opens up, negative opens down. Same thing, but right versus left. Directrix is always the line that is opposite of your vertex. So in this case, my directrix is going to be aligned to the left, and I'm going to go p units away. So I'm going to go over, if I'm at 0, 0, I'm going to go over to the left 1/4 because my P is 1/4. And so that line, if I made like a little dash at 1/4, I know it's kind of hard to see. That dashed line right there, I call that my directrix. And would that be an x equals or a y equals?
X equals.
An x equals. So x equals negative 1/4.
Can you just freehand that?
Uh-huh.
On a test, would you be specific about
No, I wouldn't. I'm mainly looking at like the things that you have in the blanks, not necessarily the graphing. I'm not too specific. Yeah, it needs to open the right way. You need to graph your directrix. You need to graph your focus. So kind of think about the directrix is going away from where it's pointing and the focus is going towards where it's pointing. So think about when you're focused on something, you're going towards your goal. Like you're pointing towards where it's pointing. So my focus in this case is going to be at 1/4. So this ordered pair would be what? Like, because the focus is only a point and the directrix is a line. So the focus would be at 1/4, comma, 0. And you can follow the, all of this has this. So x minus, or h minus p, h plus p. But I like to think about graphing it, putting the focus towards where it's pointing, and then taking the directrix away. So find what your p is, and then do it that way. If we have a vertical axis, it's the same thing. So we have an x squared, and so that's going to point up or down. If you have a positive x squared, it's going to be opening up. A negative x squared is going to be opening down.
Wait, I have a question.
Yes.
Why isn't the focus 0, negative 1/4?
Because it's on the x-axis. So you go to the right 1/4, and then you go up or down 0. So if I were to graph x squared, you can put that in your calculator, or I feel like we've done enough of these. We know it looks something like this. If I were to write this out matching the formula, it would be x minus 0, so x minus h squared equals 1 y minus 0. This is just without any translation. So my vertex would be at 0, 0. 4p equals what? 4p equals 1, so my p would be 1/4. My axis of symmetry is going to be at where I can cut that in half. So what would that line be if I folded that in half? X equals 0. This is my axis of symmetry. And I'm going to put a dot at my vertex. Then for my directrix, I go away from the parabola. My focus, I go towards the parabola. So what is the line that is away from the parabola? The directrix, and what would that equation of the line be?
Y equals negative 1/4.
Y equals negative 1/4, good. And my focus, the ordered pair, would be at 0, 1/4. So in this case, it really helps to graph because I don't like doing these without graphing because I can't see the parabola. It's hard for me to look at these things and fully understand it. So my suggestion is to graph it and then plot your point and your directrix first, then fill in the blank. Okay, so let's look at number 1. First, let's decide what type of parabola is it. Is it an x squared or is it a y squared? So is it horizontal or vertical? It's an x squared because it is a vertical. So since it is a vertical, that means that the equation is going to match the one that is x squared. So x minus h squared equals 4p y minus k. So things that I can fill in based off of this graph. I can go ahead and know what the vertex is because it is at the point where it opens up. So the vertex would be at what ordered pair? 0, 0. I can also fill in my axis of symmetry because that is the line that I could fold it in half. So my axis of symmetry is this dashed line which I would say is what? Y equals 0 or x equals 0?
X equals 0.
X equals 0 because it's vertical. So vertical line is x equals. Then we're going to fill in the directrix and the focus, and then we can fill in what our P is. And so directrix is this line that is below the parabola. So what is the equation of that line? Y equals -3. And my focus is the point that is towards where the parabola is going. So 0, 3. And my P is always the distance from my vertex to the focus and my distance to the directrix. So it is just your distance. Isn't right. Distance. It's not right. Distance to focus or distance to directrix. So how many points do I have to go to get from 0 to 3?
3.
3 points. So my P equals 3. And so now I have all the information that I need to fill in the equation. So my H, my K, my P, and that's all I need. So my equation would be x minus 0 squared equals 4 times 3 y minus 0 squared. Then I'd want to simplify that because I don't really like the zeros and all of that. And I need to multiply the 4 times 3. So my final answer would be x squared equals 12y. Not squared. You're right.
Dadgummit.
Oh my goodness. Okay, I want you to try number 2. So if we have a horizontal, then the formula for horizontal is what? Y minus k squared equals 4p x minus h. My vertex is at 0, 0. Then my axis of symmetry is where I cut the parabola in half. It is a horizontal line, so that means that it is y equals 0. My directrix is the line that is opposite of my vertex, so it would be x equals -1/2. My focus is the point that is towards where the parabola is going. So that ordered pair would be what? 0.5, 0, or 1/2, 0. And my P is always going to match what my focus is. So my P equals a positive 1/2. Because it's the distance from the vertex to the focus. So then if I plugged in everything, it would be y minus, if I have h and k, y minus 0 squared equals 4 times 1/2 x minus 0. So then simplify that, you get y squared equals 2x. And then you are done. Okay, let's flip to the next page. So just based off of this one, what kind of parabola is it? Is it a vertical? Is it horizontal? Is it open? Left, right, up, or down?
It's a horizontal.
It's vertical.
That's what I meant.
It's vertical. And does it open up or down? Is there a negative sign anywhere?
Down.
Yes, there's negative, so it would be opening down. So even though the negative is over here on the right side, it's still going to be opening down, because if I divided everything by negative, then the negative would just go to the left. So you can also put this in your calculator and graph that. So if you were to graph this in the calculator, it would be y equals -x squared. So based off of this, if I were to expand this equation to match the vertex form, it would be x minus 0 squared equals -1 y minus 0. So just based off of that, I can tell that my vertex is going to be where? At HK, which would be 0, 0. Then you plug it in your calculator and you'll see that it points down, or you could plug in points. My axis of symmetry would be where? It would be at 0, and it would be in x equals 0. My directrix is away from my parabola. My directrix is equal to, so -1 equals 4p, but I always want to find p. Does that make sense? So that number right there equals 4 times p, but I just want to find what p is, because that's what's going to tell me what my focus and my directrix are. So p would equal what? -1/4. So I'm going to be going away from the vertex, -1/4. And so my directrix would be at, I'm going away, +1/4. And would that be a y equals or x equals? Y equals.
Wait, why would your directrix be the opposite?
Because your directrix always goes away from your vertex. Yeah,
So
it's
you
like
take the
repelling
P
away. Yeah, so it's
And
all.
always turn it around.
Yeah, this is always the opposite of what your P is, and then your focus is the same sign as what your P is. So focus would be 1/4 towards the arrows, towards where it's pointing. So what would the ordered pair of the focus be? 0, -1/4. Good. Okay, try number 4. So it's the same process, but now it's going to be horizontal because you have a y squared. Would it be pointing right or left?
Right.
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 So these are translated, meaning that they have an H and a K, and they're not going to be centered at the origin. So I'm just going to go ahead. The first thing that I do when I see an equation like this is I label my H and my K, and the 16 is equal to 4 times P. So what type of parabola is this? Vertical or horizontal?
It is a
Vertical.
Vertical. Does it open up or down? Up. Because it's positive. So vertical, up. It's asking me to identify the vertex. So my vertex would be at HK, which would be what? -3, -2, because you take the opposite sign. Okay, so anytime it's in parentheses, you take the opposite sign. So I'm going to go ahead and plot that at -3, -2. My axis of symmetry, so I'm just going to, I know that it's a vertical and it goes up, so I just draw. I'm not going to be too picky about the points. I just want to know that it's vertical and it's pointing up, okay? Don't make it really, really wide or really, really skinny. Just kind of do your best. I'm just looking at the direction and then whether it's pointing the right way. And so my axis of symmetry then would be at what line?
x equals -3.
X equals -3. Perfect. Because you always take your H for vertical and you take your K for horizontal. Then my directrix. So my directrix is going to be a line away from the vertex. So if my vertex is at -3, -2, I need to find what my P is. So up here I said that 4P equals 16. So P equals what? 4. So if I start at my vertex right here, and I'm going to draw my directrix, that means I'm going to go 4 units away from the vertex. I'm going to be going down. So if I'm already at -2, I'm going to count 1, 2, 3, 4. And I'm going to be at this line right here. So I'm 4 units away. And so what would that line be? Y equals -6. Perfect. Then my focus, I'm going to be going towards where the parabola is pointing. So I'm going to be going 4 units up. So I count 1, 2, 3, 4 and I put a dot there. That is my focus. And so that ordered pair would be -3, +2. Perfect. Okay, go ahead and try number 6. Okay, so for 7 and 8, we're now given 2 pieces of information. It says write an equation of the parabola with a vertex at 2, -1, and a focus at 5, -1. So how I'm able to tell whether it's horizontal or vertical is I look and see what numbers they have in common. Like, are the x's in common or are the y's in common for both of those? So what's in common for vertex and focus? The y's. So if they're all on the same y-axis, like the focus and the vertex, then it's a horizontal. So since it is a horizontal, then I know that the equation will be y minus k squared equals, you don't have to, x minus, I'm just writing it so that we know kind of what we're working with. You'll have an equations sheet. Do what?
How do you know it's horizontal?
Because the y's are the same. So if I had like a graph and the focus and the vertex were on the same line, then it would be something like this. Like, it would be horizontal because they're all on the same line. So that's a poor drawing, but you kind of get the gist that they're on the same y-axis. So if the y's are the same, it's a y squared, which means it's horizontal. The x's are the same, it's an x squared, and it's vertical. So it gives me the vertex, so that's h and k. So I can go ahead and fill that in. Then my focus, so if I'm wanting to figure out what my focus is, I know that the distance from my vertex to my focus are how many points? Like if I'm going from 2 to 5. 3 points. So then my P equals 3. Because P is your distance from vertex to focus. So I can just now fill in H, K, and P. And then simplify and I'll be done. So y minus k, so plus 1 squared equals 4 times 3 x minus 2. So do you see how I got that? I filled in h and k, so 2, -1, and then I got my p equals 3 by finding the distance from my vertex to my focus, which was 3.
It's just the opposite thing.
The distance from my vertex to the focus was from 2 to 5. So I plugged in for P, I plugged in 3.
Wait, so like 5 minus 2 squared and then square rooted?
No, just 5 minus 2 is 3. Then I plug in P, because that's my P, is the distance from vertex to focus. Then I just plug that in. So that would be my final answer.
Nice. Oh, yeah. Yeah.
I'm so scared of it.
Okay, so what I did, since it's a parabola, I moved the y over. Then I completed the square, so I added 16 to each side. And then you can leave it like this. Or if you wanted to move the negative over, you could also write it with the negative on the left as well. But you only do completing the square one time on a parabola. Don't do it twice. Does that make sense?